What is going on, guys? Welcome back to another video for the SQL tutorial series here on Neural 9. In this video today, we're going to cover relationships between tables and joins. So let us get right into it. Alright, so up until this point in the tutorial series, we have only been working with one table, namely the people table. And today we want to look at relationships between multiple different tables. So for example, we have the people table and a person can own one or multiple things. And a thing can maybe be owned only by one person or it can be owned by multiple people. And then again, you can also have relationships between the same table. So people can be connected to other people. So you might have a friendship relation. We're going to talk a little bit about that. And then we're also going to look at joins, which are things that allow us to do select statements across multiple tables so that we can join multiple tables on specific columns, and then we can have select statements that combine these tables so that we can have more data than just the data that is present in one table. This is what we're going to do today. And for this, we're going to start again by using TutorialDB, which we were working on all the time. And we're going to drop all the tables that we already have because I want to start here from scratch. So drop table if exists. People. I don't know actually if in my case I have more tables here. So let me just see, use TutorialDB. No, we don't have any other tables. Okay, so we only have the people table and we're going to drop that people table so that we can create it again from scratch. So create table if not exists. Come on, exists people with the following fields. We're going to have, again, an ID, integer, primary, key, auto, increment. I'm not sure if I'm actually changing something here, but I'm going to go with name, which is a varchar 255. I just like to start from scratch so that I don't mess up anything. Age is going to be an integer. Height is going to be a float. And then we have the gender, which is an enum, male, female. And I think actually this is the same structure that we had before. So maybe you don't have to drop the table. I just do it for to make sure that I don't work with a different table here. So create table if not exists people. And now the idea is to have another table called things, and things can have an owner. So we have different types of relationships when it comes to database relationships or table relationships. We have the so-called one-to-one relationship. We have the one-to-n relationship or the n-to-one relationship. And we have the n-to-m relationship. These are also called one-to-one, one-to-many, many-to-one, or many-to-many. And the idea is that you can have certain things that can only work on a one-on-one basis. So you might say, a thing can be owned by one person only, and a person can own exactly one thing. So that would be a one-to-one relationship. Now, it's not realistic because things can usually sometimes be owned by multiple people, and a person can own multiple things. But if we say that a person can own exactly one thing, and a thing can be owned exactly by one person, that would be a one-to-one relationship. If I say, okay, a thing can only be owned by one person, but a person can own multiple things, that would be a one-to-n relationship. One person can own multiple things. A thing can only be owned by one person. And of course, I can swap that to change the cardinalities. And then we also have the idea that multiple people can own the same thing, and a thing can be owned, and people can own multiple things. So this would be many-to-many in both ways. That's the basic idea, and we're going to start here with a simple one-to-one relationship. We're going to say create table if not exists things, and we're going to keep it simple here. All we're going to have is we're going to have a thing ID, which is going to be an integer, primary, key, auto, increment. We're going to have a name, which is just going to be a variable character 255 not null. And we're going to have a description of the thing, which can be null. We don't have to provide it. And then we want to have an owner. And what we do here now is the owner is not going to be of type person or people. It's going to be of the type that the primary key of the people is. So Remember, the primary key is the identifier for the individual rows. So a person is identified by the PID. The PID is an integer. So when I say that the thing has an owner, I have to provide that this is also an integer, because the integer, of course, relates to the PID, or is the data type of the PID. Now, this right now, if I leave it like that, and of course I would have to add a foreign key relationship, so I have to say here foreign key, meaning that this is the key of another table. So here it's just a foreign key, here it's just a field, but this field here is the primary key of the people table. And I say that by saying foreign key T owner references people PID. Or, yeah, people PID. So this basically says we have this owner field, which is just an integer, and this integer is actually referencing the primary key of the people table. Yeah. So that is the basic structure here. Now, as of right now, as we look at this, this is a one-to-n relationship. Why? Because a person can own multiple things, because all I have to do to say that a person owns multiple things is I have to add new things, and I have to have the same person here as an owner. That is currently a one-to-n relationship. A thing cannot be owned by multiple people because I only have one owner field here. I don't have a collection. I don't have any other structure here. I only have one number that each thing can be assigned here as an owner. If I want to say that only a one-to-one relationship is possible, what I have to do is I have to say that this is unique. Because then, of course, think about it, every owner, every number for the owner ID can only occur exactly once. Meaning that if I have the ID 1 present in the table, it cannot be present in any other row because it's unique. So it would be a one-to-one relationship. Like this, it would be a one-to-n relationship. And of course, I can also flip it. If I want to say, okay, a thing can be owned by multiple people, but a person can own only one thing, I would have to remove this field here. I would have to say p thing that the person owns, and this p thing would be a foreign key referencing the t owner TID. But that's, of course, not very realistic. If I want to model the idea that we can have multiple owners and we can have multiple things being owned by the same person, then we want to have a third table, or we need to have a third table, because that is how we model many-to-many relationships. We need to say that there is a third table, create table if not exists. In this table, we could call it ownership, keeps track of the ownerships. So we have here O underscore owner, which is an integer, O underscore thing, which is also an integer, because of course here we reference again the PID and the TID. And then we need to say here primary key. And we can have, this is something new, we can have multiple fields forming a primary key together. So this alone is not a primary key, this alone is not a primary key, but those together are a primary key. They identify a row. They have to be unique and not null. So primary key, and then in parentheses, I just say O underscore owner, O underscore thing. And then, of course, the same thing as above here. I need to reference both these fields as foreign keys. So foreign key, and then I say O underscore owner references people PID. And then I can copy this, and O underscore thing actually references things TID. So that now, and of course I can then remove this field here, that now models the idea of having a many-to-many relationship. So this now means that a person can have multiple things, because all I have to do is I have to say which person owns what. And then I can also have the same thing in the table multiple times. I can have the same owner. I just have to have each combination only once in the table. Yeah, so that is a many-to-many relationship. Now, before we go any further with the inserts, or actually with the next table, we're going to start with the inserts here because I want to show you with some sample data how we can do some queries on this. And for this, I'm going to just copy paste some sample data. You can either generate your own sample data, you can copy it from, or you can type it from this video, or I would recommend just go to ChatGPT, provide it create scripts, and say, give me some sample data to work with this, here. So we're going to just copy here from my second screen into the clipboard these insert statements. So I'm going to show you here what I'm doing. So we have the people table that we modeled here. We have here just some basic names, some basic ages, some basic heights. I think those are now in, I don't know what those are now in meters. And then we have genders, and then we have down here things with some description. I also have, this is important, I have a person, Mike, non-owner, which is not going to own anything. And I'm going to explain here why we need this person in a second. And I'm also going to have a thing that is not owned by anyone, because all these other people are going to own things. All these other things are going to be owned by people, but Mike, non-owner, will own nothing. And the MATLAB fan club membership will not be owned by anyone for obvious reasons. So this is an item that is not owned by anyone, and this is a person that doesn't own anything. And here we have the ownerships just referencing the different IDs. So person 1 owns item 1, person 1 also owns item 3, and so on. And then we also have here 4 owns 5, but also 2 owns 5, so they share ownership in this case. And now the question is, how can we actually select something from this structure? So how can I say, how can I formulate certain queries? Before we get into any specific queries, I just want to introduce here now the concept of a join and the concept of the 4 different joins that we're going to look at. And for this, I'm going to first run all of this. So we're going to create table people. What's the problem here with things? Oh yeah, of course I removed the owner, so we're going to remove the foreign key constraint as well. Then the ownership. Then we insert data. Okay, this is now still with the owner. So actually, let's just keep the owner as well. Why not? So let's just say it's going to be an integer like this. Now I need to drop a table to create it again. Things, there you go. Cannot drop table. Yeah, of course we need to drop. This is another thing. When you drop tables, you need to make sure that you drop all the tables first, so that you somehow make sure that the tables are not used somewhere else. So you need to first drop ownership, then things, and then people. Then we run this again, run this again, run this again. Insert data, insert data, insert data. What's the problem here now? Ownerships doesn't exist. Is it called ownership? Yeah, without an S. There you go. Okay, so this is now our data. And what we can do, of course, remember, we can say select everything from a table. Or select, let's say, P name from people. This is something that we can do. And then we get the names. But now what I want to do is I want to say, okay, give me the names and also all the items that these people own. So I want to have a combination. I want to know, okay, this is the name of the person and this person owns this thing. This is what I want to have here. So in order to do this, what I have to do is I have to introduce a join. So I can say here, select P name, and then, for example, T underscore name from people. And now I have to join the people table on a specific column with the things table. Or in this case, we could also do it with the ownership table. We're going to do it first with the things. This is why we had the T owner here. So this is, again, the 1 to N or the 1-to-1 relationship. Now, right now, it's 1 to N. This might be a little bit confusing now because we have both. We have the 1 to N here, and we also have the N to M down here because we have also a separate table. But I kept both to show you the concept here. What we can do is we can say, okay, P name, T name from people, and then we can specify a join. And the basic join that we can do is the inner join. I'm going to explain here now what this means here in a second. People inner join things on people dot p underscore ID equals things dot t underscore owner. So we basically say, okay, people PID is the same thing as things dot t owner. Join these tables on these two columns, match the records, and select them. And this would give me this output here. We have the person and the thing that this person owns, as you can see. Now, what you can see here, and this is the concept now of the inner join, you can see that Mike non-owner is not listed. And you can also see that the MATLAB fan license is not, or fan membership, is not listed here either. So things that have no match are not listed. This is the concept of the inner join. We only display the records where we have a match. So the thing owner has to be a person, has to be present, and the person has to actually own something. Otherwise, we're not going to include these things in the result set. Now, if I want to include all the people, no matter what, no matter if they own something, so I also want to see Mike non-owner here, but I don't want to see that he owns anything, so I will see null here. But I want to have Mike non-owner listed in the result set because I want to have all the people. Then I have to do a left outer join, so just a left join here. Meaning everything from the left table, which is this one here, this is left, this is right, everything from this table will be included even if it has no match. So right now you can see we have all the people, also Mike non-owner, but he owns nothing. If I want to do it the other way around, I want to have all the things, including the MATLAB fan membership, but not all the people, then I can do a right join. Now I have this item here as well, but no one owns it. There is also the concept of a full outer join, but we're going to cover this in the next video because I have to introduce something new so that we can do a full outer join in at least my SQL. There are, I think, database systems where you can just do full join or full outer join. I don't think that it works like this in MySQL. So yeah, we're going to talk about this in the next video. But one thing that's also important to mention is that when you just use join, like this just does an inner join. And then also there is the concept of the cross product of the cross join. You can just say people cross join things, and then you get the cross product. So every item matched with every item from the other table, which, you know, if you need it for some reason, you can do it. So those are the basic joins. What we can do now is we can try to query specific things here. So for example, we could say, give me all the things that share ownership. So I can say, give me all the people that own the same thing and also the thing that they own. So what I can do for this is I can say select, and then I can say p p1 dot p underscore name as person 1, for example, then p2 p name as person 2, and then t underscore name as shared thing, like this. And of course I use uppercase for all these things. So those would be the fields, and now I have to specify where I get them from. And I can say the following thing: from ownerships or ownership 01 join ownership 02 on 01.o underscore thing equals 02 o underscore thing. So we access the same table twice. We want to have the same thing, but we're going to add the condition that 01 underscore or actually 01 underscore 01 dot o underscore owner is not equal, so is different than 02 o underscore owner. And then we want to join this again with people p1 on 01 underscore o dot o underscore owner equals p1 dot p underscore ID. And we copy this. P2 is the owner of the other table. And then the thing We join it on things as well. Things t on o1 dot o underscore thing equals t and then t underscore id. So what are we actually doing here? We're accessing the ownership table twice with the condition that when we find a thing that is present in both tables, so we look at ownership 1, ownership 2, which is the same table, of course, but we look at it, we have to find two different owners that own the same thing. So the thing is the same, the owners are different. This is the condition here for the join. And then we say, okay, the owner 1 has to be person 1, the owner 2 has to be person 2, and the thing is the thing, which of course by this condition here is the same, and those people are of course different because of this condition, and then give me the shared things. So I run this, and you can see here, Jane Smith and Bob Brown and Jane Smith, which is redundant of course, own a watch. They share this thing, which is of course true as we can see here. They own both the fifth item here. All right. Yeah, so that is a simple query, or actually not too simple probably for a beginner, but a query that you can do just with joins without any more advanced structures here. Now, let us now also introduce another table. We're going to do it up here, a friendship table. So we can say here, create table if not exists, friendship, or friendships, plural. Actually, I should have also called it ownerships, but doesn't matter now. And we're going to say that this table here is going to have a friend, or f underscore friend 1, which is going to be an integer, f underscore friend 2, which is going to be an integer, and we're going to say that the primary key here is going to be f friend 1, f friend 2, and then we're going to say that the foreign key constraint for f underscore friend 1, this references people p underscore id. And of course, I copy this one more time for friend 2 because of course it's the same reference to p underscore id for people. I can run this now, and now we have a friendship table. For this, again, I'm going to copy some sample data here, just so I don't have to type it while making this tutorial. So I'm gonna load it into my clipboard. I'm gonna paste it here. There you go. And now we have just some basic friendships, also with comments here, so that you have the overview of what is actually happening here when we use these IDs. And now I can say, for example, that I want to see all the friendships. So I want to see the names of all the people that are friends. So we can say select p1, which is person 1, dot p underscore name as friend 1, p2, p underscore name as friend 2, from friendships, and then join people p1 on friendships dot f underscore friend 1 equals p1 dot p underscore id, and then I can copy this and do the same thing for people 2 and friend 2. So like this. And this just lists, no it doesn't, okay. Oh, did I execute this? I think not. There you go. So now we have all the friendships that are present in a table, but not listed as IDs, but as names, as you can see here. Yeah, and of course we can do some more combined queries here as well. You can do stuff like, okay, show me, you know, if I want to have an item, which friend would I have to ask? So for each person, show me a friend that owns this item or something. You can just combine joins the way you want. You can just add more and more joins. You can add left joins, right joins, inner joins. You just combine the tables, you join them on the foreign keys, and then you can query across tables. It's a very simple concept actually. So when you see these two examples, if you understand these two examples, you can basically model any other example here, like joining across 3 different tables, 4 different tables, friendships, ownerships, people, and things, whatever you want. But yeah, this is how you model relationships in a MySQL or in SQL in general, in a SQL database, and how you do joins. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.